All right, here's our video for the practice problems for solving rational equations. These are the same form as your notes, but they do have some twists to them that we didn't talk about in the notes. So we'll talk about that here in this video. In this first problem, we are going to create our common denominator from each of these individual denominators. Remember, minus and plus groups these two things together, so you can no longer do math on them individually. So there, you can do math on them now as a group. So this group we want in our common denominator, so n minus 1, and this grouping also. So we're going to rewrite the fractions. So we couldn't factor, we created our common denominator, and now we rewrite the fractions to match this common denominator. So the first fraction needs the n plus 4 in its denominator. So, and we multiply that bottom and top. The second fraction needs the n minus 1. So we multiply it bottom and top. So now that we did step 3, we're going to do step 4, cancel the denominators, and then start on step 5, solve the remaining equation. So our remaining equation is whatever's in the numerators. So we have the grouping n plus 4 times 3 equals 2m times the group n minus 1. So I'm going to start here by doing distributive property. 3m plus 12 equals 2m squared minus 2m. And now you'll notice that there's an m squared and also regular m's. This is my clue that I'm probably going to have to factor at some point. So in order to test that out, I need to set everything equal to 0. So I'm here at this step. So to do that, I'm going to move the 3m plus 12 over to the right. And I'm moving it to the right because this m squared term has a positive value in front of it, and I want to keep it positive. So I don't want to move this to the left. So I'm taking everything on the left and moving it to the right. So minus 3m minus 12 minus 3m minus 12. So these cancel on the left, leaving me 0. And on the right, I have 2m squared minus 5m minus 12. And because this is standard form, my value in the front is not a 1, it's a 2. So I am going to need to do slip and slide here. So I take the 2, slip it down to the n. Now I do the cross on this right here. What multiplies to the last term and adds to the middle. Negative 8 and 3. So I write that in factored form. Now I divide out that 2 that I slipped down in the beginning and simplify if I can. So 8 over 2 is 4. And 3 over 2 doesn't simplify, so I slide the 2 back up front. Now two factors multiplying to 0 means, or these two groups multiplying to 0 means that each group individually can be equal to 0. So I'm going to come over here and I'm going just to do that. Take each individual group and set it equal to 0 and solve that equation. So m minus 4 equals to 0. I add 4 to both sides and get m equals positive 4. Then I'm going to take this group, 2m plus 3 equal to 0. I'm going to subtract 3 to both sides and then divide by 2. So those are my answers. On the next problem, we do have to do step 1, factor the denominators. So the first one can't, the second one can't, but this last one can. What multiplies to the last term and adds to the middle, this middle coefficient, remember, is a 1. And that's going to be 4 and negative 3. So I'm going to rewrite this as n plus 4 times n minus 3. So I factored. Then create the common denominator. The group denominator has have each of these individual groups in it. So I need an n plus 4 I need an n minus 3. And this last one already has both of those, so I don't need to add them again. So this is my common denominator. So now rewrite the fractions to match. The first fraction needs the n minus 3, top and bottom. The second fraction needs the n plus 4. And the last fraction's good. So I've rewritten them. Now I'm going to cancel the denominators and solve the remaining equation. So I'm going to write that down. I have this group n minus 3 times 7 minus 2 times n plus 4 equals 2n minus 9. Now here I'm distributing a negative 2. So be sure when you distribute here that you include that negative. And then here I'm distributing a 7. So 7n minus 21 minus 2n minus 8 equals 2n minus 9. So on the left, I'm going to combine like terms. I have 7 minus 2n is 5n. Negative 21 minus 8 is negative 29. And now I have this equation. So let's think about how this equation is different from when we solved here. In this problem, we had m squared and m to the 1. So that was my clue. I was going to have to do a factoring method. But here, my variables are exactly the same. So here what we're going to do is move all the variables to one side and the constants to the other, and then solve from there. So I'm going to move n's to the left by subtracting 2n to both sides. So now if all my n's are going to be on the left, I need to take this constant and move it to the right by doing the opposite, which is plus 29. So the 29's cancel on the left, and the 2n's cancel on the right. And I'm left with 5n minus 2n, or 3n, and negative 9 plus 29, which is 20. And then my last step is just to divide by 3. So n equals 20/3. And then on this last problem, we don't have any denominators, excuse me, that need to be factored. We are missing a denominator here. Remember, this is really over 1. So when we go to create our common denominator, we need this first denominator in our common or group denominator. We need a 1. You could write times 1 here, but I'm not going to. Remember, multiplying by 1 doesn't change anything. And then we need this last denominator. Remember, this addition groups the p and the 6 together. So they are not individuals anymore. They're one group. So I'm going to keep parentheses around it in my group denominator. Step 3, rewrite the fractions to match the common denominator. So the first fraction has the p. It also needs the p plus 6, top and bottom. The second fraction has 1. It needs both of these things, a p and a p plus 6, top and bottom. And then the last fraction has the p plus 6, and it needs another p. So I have rewritten the fractions. Now let's cancel the denominators. In the first fraction, I have this group, p plus 6 times 2, then plus 3 times p plus 6. And on the right-hand side, I have 7 times p. So I'm going to do distributive properties where I can. I have a distributive here with this 2, distributing into both terms inside the parentheses. So 2p plus 12. In the second grouping, I'm actually going to distribute this thing, 3p. 3p times p is 3p squared, and 3p times 6 is 18p. Now I want you to notice we have the situation again where there's a squared variable and a regular variable. We are probably going to have to factor. It is sometimes happens that one of the variables will cancel out completely, but but usually we end up having to factor. So before I start, so let me say that means setting equal to 0. So before I do that, I'm going to combine like terms over here. 2p and 18p combine, and I'm going to start writing this in standard form. So my squared term first, then the p to the 1, or linear term, which is 20p plus 12 equals 7p. So getting this equal to 0, my best bet is going to take the 7p and move it over. That'll be the easiest thing to do. So now I have 3p squared plus 13p plus 12 equals 0. So this is a quadratic. The first term is not a 1, the coefficient. So I'm going to have to slip and slide. So slip the 3 down to the n, which gives me p squared plus 13p plus 36. All right, so this is a slip and slide. We are going to now do cross for here, what multiplies to the last term and adds to the middle. So 9 and 4 will work here. So p plus 9 times p plus 4 equals 0. Divide by the 3 that we multiplied in the beginning, and that gives me p plus 3. Slide this p up front. 3p plus 4 equals 0. So now I'm going to set those equal to 0 individually and solve. So p plus 3 equals 0. Subtract 3 to both sides. P equals negative 3. 3 plus 4 equals 0. Subtract 4 to both sides gives me 3p equals negative 4. And then divide by 3 gives me negative 4 thirds.